What's poppin', dogs? Mr. Allen here, graphing a rational function in this video that is already in factored form. How wonderful. If it's not in factored form, that's the first thing you got to do when graphing rational functions. But we still got a lot going on in this one. So first thing, domain. How do I figure out what my domain restrictions are? Well, I got to look at my denominator because I can't divide by 0. So anything that makes that denominator 0 is part of my domain restriction. All right, so I cannot equal -2, 3, and +1. All right, now some teachers will ask you to do like an x such that x cannot equal this, and all real numbers and all these other things. I just write down what it can't equal. So if your teacher wants a little bit more, make sure that you do what they want because they're the ones that are grading your tests, right? But I just go with the basics here, okay? It's nice and clean, easy to read. Holes. Do we have any holes here? Well, holes, aka removable discontinuity, would be the more formal math word, or what we remove. So if I cancel something out, and I'm going to rewrite this in a simplified form here, 2x minus 5 over, we have x plus 2, x minus 1 left. What I remove, that would give me my x coordinate of the hole. Note that I said x coordinate of the hole. So I have a hole at x equals 3, but what's my y coordinate? Well, how do I figure that out? How about I plug back in and evaluate? So I can do so in my simplified guy right here, and I'm actually going to do that off to the side over here so it's out of the way of all of our graph and whatnot. So if I plug this in, this 3 here, into my simplified guy, I'm going to have, let's see here, 2, 3 goes in the parentheses, minus 5, and then I have 3 plus 2, so 3 plus 2, and 3 minus 1. Okay, so we got 6 minus 5 is 1. Then we have 5 times 2, that's 10. So just double check everything here. I'll plug 3 in. Yep, 6 minus 5. I plug 3 in, that's 5 times 2. Okay, cool. So we have 1/10. So it'll be really, really close. 3, 1/10 is really close to my y-axis there, right? Sorry, my x-axis. Really, really close to my x-axis. So I'm not going to be able to get right exact 1/10, but at least if it looks like that and you got it written down here, good to go. So now vertical asymptotes. Well, vertical asymptotes are whatever's left in my denominator after any cancellations can be done. I have 2 factors here, so that means I have 2 vertical asymptotes. And those are going to be, let's see here, what makes this 0? -2, so x equals -2. And x equals +1. So let's plot those. I'll use a ruler here. X equals -2. It's a vertical line. Pop some arrows on it. And then x equals +1. Vertical line. Pop some arrows on it. Cool. How about my horizontal asymptote? Do I have one? I do, right? Because it could be oblique. If my numerator degree is larger than the denominator, then it's oblique. But here, because it's in factored form, it's actually like a little bit harder to see. But my degree in my numerator is 1. My degree of my denominator here is x times x is x squared. Or I can look at the original. It was x squared over x cubed. In any event, the degree in the numerator is less than the degree in the denominator. So it's y equals 0. So let's plot that now. Y equals 0 is just the horizontal line along the x-axis, right? Not what I said, the y-axis. Whoops. Brain fart. Okay. So there's my horizontal asymptote. And this one's getting interesting. We got y equals 0. I got 2 vertical asymptotes. This is fun. Any other features? Well, how about x-intercepts? How do I get an x-intercept? Well, an x-intercept will be figured out by whatever would make my function 0, right? Whatever would make my output 0, because my y value would have to be 0 anywhere on the x-axis, okay? So I know this ordered pair, if it were to exist, is something comma 0. Well, how do I make a rational function 0? It's not by getting my denominator to be 0, because if I did that, it's undefined. But if I got my numerator to be 0, the 2x minus 5, if I got that to equal 0, then I would have an x-intercept. So if I set this equal to 0, 2x minus 5 equals 0. Hopefully that's still on the, there we go, right in the corner. Add 5, I get 2x equals 5. Divide by 2, I get x equals 5/2. So here it's going to be 5 over 2, comma 0 for my x-intercept. That's like, what, 2.5? 2.5. Interesting. I have a point. I have a point on my horizontal asymptote. I thought you can't cross the asymptotes. You can, however, cross a horizontal asymptote. The only thing that the horizontal asymptote does is it tells you what's going on the far ends of the graph. So far left and far right of the graph, it'll tell me my end behavior. So I know my end behavior is going to be approaching 0 on the left and right hand side, but I can cross over and come back to horizontal asymptotes. I'm never going to cross a vertical. Right? That's never going to happen. But I can cross a horizontal, okay? And it's going to happen here. How about my y-intercept? Well, how do I get my y? If I plug in 0 for x, it's going to be on my y-axis, right? So let's plug in 0 for x. I guess I'll do so in the simplified one here. That'd be negative 5 over 2 times negative 1, right? So negative 5 over 2 times negative 1. So that'd be 5 over 2. Okay, interesting. That is interesting. 5 over, okay. 0, comma 5 over 2. That is a coincidence, guys. That is a coincidence. It's not necessarily going to be that, right, where they flip-flop each other. But in this case, it is. So 0 and then 5 over 2. So that's 2.5, we said. Right about there. Cool. And I have no other features. Great. So what in the heck is happening here, guys? What is going on with this graph? This is kind of a tricky one to figure out because I don't have a ton of information. I plotted my whole. I've got an x-intercept. I've got a y-intercept. The x-intercept's on my horizontal asymptote, which seems odd, but it can happen. So now we got to figure things out. So here's how you do that, okay? It deals with what's going on around my asymptotes here, my vertical asymptotes, and we're going to describe the vertical asymptote behavior later, but I'm going to do so in, we'll go with blue marker here, and we're going to do a test near my vertical asymptotes, okay? And we're going to pick values that are to the left and to the right of these vertical asymptotes to see, is my graph going like this or is it like this, okay? I know the graph is going to go here, and I know it's going to go here, but I don't know from what side it's going to be doing that, okay? It's got to come towards my horizontal asymptote, but is it from here or from down here? So the way I test that is I take a value that is just to the left of this vertical asymptote. This is at x equals negative 2. So I'm going to test out negative 2.1, okay? And I'm going to write that right here. If you have room, you can always write it up here. It's up to you. I'm just going to keep it down here and out of the way, hopefully. Yeah, we'll do it down here. Okay. Actually, you know what? Second thought. So I'm going to be writing some stuff here with the vertical asymptote behavior. I'll put it up here. Negative 2.1. That is my test value here, to the left of that vertical asymptote. And all I'm looking for is if it's positive or if it's negative. Okay, I don't care what the number is, just if it's positive or negative. If I plug negative 2.1 in here, it's going to be a negative up in my numerator. This guy's going to be negative, and that guy's going to be negative, meaning I would have a negative divided by a negative times a negative. Well, 3 negatives makes it overall negative. So I know that this graph is going to be pointing down here, and we already talked about how the end behavior is going to approach that horizontal asymptote. And you know what? If you plugged in a value and you evaluated, you'd see points roughly in this fashion right here, okay? But generally speaking, your teachers are just going to ask for you to put the key features, your vertical and horizontal asymptotes or oblique, your intercepts, and any holes, your removable discontinuities, which we've done all of that. Now I'm just placing this thing, okay? Now the next part, what's happening here? Well, I have a feeling that it's going to be doing this and back up. Because if it were to come down and through here, it would need another x-intercept, right? I can't just make my own x-intercept and have it do like a little zigzaggy thing here. No, it's going to do this and then back up, okay? But just in case you're like, I don't think I would think of that. Let's do another test, okay? So if I plugged in, let's go with negative 1.9. That's just to the right of this. So negative 1.9, what am I going to get? Well, up here, it's still going to be negative because a negative minus a negative, or a negative minus another number is just going to be more negative. Over here, that's going to be positive. Negative 1.9 plus 2 is a positive 0.1. And then over here, it's going to be negative. So 2 negatives, a negative divided by a negative is going to be a positive. So as expected here, this graph is going to be coming up like that. And then check this one out real quick. I'll do this test. 1 to the left of that is 0.9. Let's test the 0.9, okay? So the 0.9, if I plug that in, this is still going to be negative in the numerator. Right here is going to be positive. But here is going to be negative. So overall, it's positive. Okay, and again, I'm not really looking for my actual numbers, just is it positive or negative? 0.9 times 2, it's going to be a smaller number than 5, so it's going to be negative. Here, it's going to be positive. 0.9 minus 1, it's going to be a negative 0.1. So 2 negatives and a positive, it's positive overall. So this thing is going to look like this. Whee! It may dip down lower than that. It may, be coming down up and then going up that way. Not something that I know at least I would be grading for in this part. I'm just looking for those key features and general behavior around asymptotes. Okay? So there we go. We got that graph. And then last thing here, let's test this guy here. It'd be 1.1 is my test value. Oops, not 1.5. What am I doing? 1.1. Okay, so if I plug in 1.1, my numerator is still negative overall, right? 1.1 times 2 is going to be like 2 point something. Here, it'll be positive, right? Because 1.1 plus 2 is positive. And then over here, it's also positive. Okay, and again, just test if it's positive or negative values. Well, overall, a negative divided by a positive is negative. So that means that my graph is going down right here, and it's going to come up through my x-intercept to that hole, and then it will come back down to that horizontal asymptote. So it does kind of like come up and back down type of dealio, but it's just going to approach that horizontal asymptote. I know that seems weird. How am I going up and through it and back down to it? That is how these graphs can behave. But there we go. We got our graph. That was a beast. All right. And behavior time. I'll use the color of my horizontal asymptotes to do so, or my horizontal asymptote singular, because that's what dictates my end behavior. As x goes to negative infinity, as x approaches negative infinity, aka as it goes to the left, what is my f of x doing? F of x, comma, f of x is going to what? It's going to 0. And then as x approaches positive infinity, as I go to the right, I'm also going to 0. F of x approaches 0. Cool. Now, how about vertical asymptote behavior? There's a bit going on here, okay? So we have two vertical asymptotes, and we got to talk about both the left and the right-hand sides of those asymptotes. So for the first one here, as x approaches negative 2 from my left-hand side, so on this side, that negative, if you're looking at this and you're like, I don't think my teacher asked me that, you're probably in a more advanced video. But a lot of times we will talk about these things in like Algebra 2 Honors and Pre-Calc. As I approach negative 2 from the left-hand side, that's what that little negative in the exponent spot means, I'm going down. F of x is approaching negative infinity. And as x approaches negative 2 from the right-hand side, so from over here, this graph is shooting up. So f of x approaches positive infinity. Dope. Now, as we go to the other asymptote, so as x approaches positive 1 from the left, so from this side, I'm going up, right? As I approach it from the left-hand side, it shoots up. So f of x approaches infinity. And as I approach positive 1 from the right-hand side, it's going down. Yelling timber. As x approaches 1 from the right, f of x is approaching negative infinity. Dope. Dude, that was a lot. That was a lot. All right. Definitely tricky with the two vertical asymptotes when you don't have like a ton of stuff to work with. And you got to do these little sign charts. It's so you try to keep all your work in one spot and not take up too much room. But there we go, guys. Hopefully that all makes sense. Hopefully this idea here of like not really caring what the number is, just if it's positive or negative, is what tells me if it's going up or it's going down when it gets to that vertical asymptote. But a lot going on here. Rationals are tough. Got to stay organized. But thanks for watching, you guys. Hope you enjoyed the video. Have a fantastic day.